Alright, hello everyone. In this video we'll be looking at last year's June paper 2, question 3. So, we are given a diagram looking like so, just to make sure we're all on the same page. Points A, B, C, D, E and F. We have angle alpha over here. This angle is given, 63.43 degrees. This line, equation is given, y equals negative x minus 11. The coordinates of A are given as negative 1 comma t. These two lines are parallel, and AB is equal to BC. Okay, so now we all know what's going on here. Our very first question is, calculate the value of t. T being the y value of point A. So we know A falls upon this line right here, the line whose equation is, so let me go 3.1, y is equal to negative x minus 11. And we know that x value of A is negative 1, so y negative minus 1 minus 11, so that just makes positive 1 minus 11, so y is equal to negative 10, which is t. Okay, does that follow? You understand this? It falls on this line, and we have at least one value, so we can work out the rest. Good, so that's 3.1.1. 3.1.2, calculate the size of angle alpha, right here. So, probably the easiest way to do this is this line here, AF, that we've just looked at, has a gradient of just minus 1, right? So, the gradient of MF equals negative 1. And we know that the tangent of alpha should equal the gradient of AF, therefore should be minus 1 as well. Great, so now that we have tan alpha, we can use our reference angle, which should be 45 degrees. Therefore, alpha should be 135 degrees. In other words, should be 90 plus 45 degrees. Right, that's a very easy question, just 2 marks. And in question 3.1.3, we have to find the gradient of AC, this gradient here. Now, same kind of logic here. We know the gradient of AC is going to be the same thing as the tan of this angle that we're given right here. It's the same concept. So tan of 63.43 degrees. They want us to round to the nearest whole number, so this is the sort of thing you just plug into your calculator, and your answer should be just 2. Okay, good. Hope you're following so far. I'm going to erase this to look at question 3.2. Okay, question 3.2. Determine the equation of AC, this line here, in the form y is equal to mx plus k. So we actually already have this m. We calculated it in the previous question, and we know it's just 2. And we have a point already. Remember, we discovered that t is equal to -10. So this is fairly easy. We just plug in the values of a, so we get -10 is equal to 2, -1 plus k. So -10 is equal to -2 plus k. So -8 is equal to k. Now we found our constant, and we can plug it just into this equation. Y is equal to 2x minus 8. That should be our final answer. There is another way to do this. Which I may as well go over now. Okay, so let's do an alternative. Y minus y1 is equal to the gradient x minus x1. Sorry, that's supposed to be a minus. Again, we're using the values of a, because that's what we know. That will become 2, and that should be -1. So y plus 10 is equal to 2, x plus 1. X plus 2, so y is equal to 2x minus 8. And there we go, got our same answer right here. So either way you do it, doesn't really matter, come up to the same result. Okay, I'm going to pause quickly, erase this, and we'll tackle question 3.3. Okay, welcome back. We're looking at question 3.3. The question is, calculate the coordinates of C. So this should be reasonably easy because we already have the equation of this line here, we already have A, we know that AB is equal to BC, so let's go for it. Let's start with working out B. Okay, so we know it falls on the line y equals 2x minus 8 that we calculated in the last question. And we know, because it sits on this line here, that the y should be 0. So again, we're looking at B. 0 is equal to 2x minus 8. So 8 is equal to 2x. So x should equal to 4. Therefore, B should equal to 4, 0. Great. Now, let's work out how I'm going to do this actually. We know here, because B is the midpoint between these two, it's the midpoint of this line, we know that the x of C and the x of A halved, as in the average of the two, should be equal to the x of B, which we just worked out it's 4. Okay, we know the x of A, it's -1. So xc plus -1 all over 2 is equal to 4, times both sides by 2. xc minus 1 equal to 8, x of C is equal to 9. Okay, let's do the same thing for the y values. Y of C plus y of A all over 2, getting the average here, is the same thing as the y of B, which we know is 0. We can look at the graph for that, that's fine. Alright, so y of C plus -10 all over 2 is equal to 0, times both sides by 2. Y of C minus 10 is equal to 0, so y of C should be +10. Therefore, C should be 9, comma 10. 9 semicolon 10. My apologies. Okay, so to recap, we worked out the midpoint here. We know the midpoint's coordinates will be the average of the 2 points on either side. Okay, so that's 3.3.1. I'm going to need to erase a little bit to give us space for 3.3.2, but let me just write in here, these coordinates are 9, comma 10. Right. So question 3.3.2, calculate the size of angle FED. Right. So if you're unsure, I'm talking about FED, this angle right here. There's 2 ways to go about this. The first one is, let's think about angle ABE, as in this angle here. What's the first thing that you should notice? Vertically opposite, right? So, angle ABE is equal to 63,43 degrees. The reason? Vert up angles. Okay, now that we have that value, we can start thinking of some other things. I'm going to label these sub-angles here. I'll label that E1, E2, E3 and E4. Okay? Now, another thing we can use here are these parallel lines. There's a few ways we can use it. I think probably the easiest way is to think of our F shapes, our corresponding angles. Yeah, in order to get that E2. So we can say angle E2. Remember, if we label something on the graph, we're allowed to reference that name, that label that we've given it. We can say it's also 63,43 degrees. Y, corresponding angles, DE parallel AB. Cool. So now that we have that, we can work out E1 over here. Actually, we could have done it a little bit earlier as well. So angle E1 is equal to 180 degrees minus 135 degrees. Why is that? It's angles on a straight line. And that is a total of 45 degrees. So, angle FED, same as angle E1, is angle E2, which is 63,43 plus 45. That's the sort of thing you can put into your calculator. I did this beforehand, so I don't have to waste time pressing buttons. 108.43 degrees. Okay, that's method 1. I think, yeah, that's a good method if you're able to spot things like vertically opposite and corresponding angles. If you're better at spotting things like co-interior angles, however, the second method might be more for you. E3 over here and E4 together can form a co-interior angle with this side of B. Right, so let's say angles E3 plus E4 is equal to 63,43 degrees. Sorry, 180 degrees minus that. The reason co-interior angles DE parallel AB. From that we should get 116,57 degrees. Okay, now that we've found this whole thing, we can use angles around a point. Right? So if we go F ED is equal to 360 degrees minus angle alpha, which we worked out a while ago, minus that here, 116,57 degrees. Angles around a point. Again, use a calculator, you don't have to do this in your head. There we go. Again, same answer, either way. Yeah. Either's a fine way to do it. This one's a bit quicker. Lots of people make mistakes with co-interior angles though, so it's kind of your choice either way. Right, okay, I'm going to pause, erase the board, and we'll look at question 3.4. Alright, so question 3.4 is an interesting one. They say G is a point such that E, A, G, C is a parallelogram in that order. So what I recommend here is just kind of using your ruler, kind of gradually shift it such that you can create a parallelogram. The point would land up somewhere around here. Let me actually use green so it doesn't interrupt other things. You can imagine a dotted line to G, goes all the way to A, goes to C. You can see how it's not the best parallelogram in the world, but you can see what I'm going for here. Actually, G would be a bit closer to here. That looks a bit better. Okay, so G is a point creating a parallelogram. Determine the equation of the circle centered on G that passes through point B. So we have to imagine a circle passes through point B and it's centered on G. Okay. As a reminder, equations of a circle look like so. Y minus B squared plus x minus a squared equals r squared. These two brackets, you can swap them around, it doesn't matter. Okay, so how do we start with this? There's I would argue the best way is to start with trying to find G, right? So let's think, what's our y value of G? Now you might already think, oh, it's going to be on this line, this y equals 0 line. Don't trust your eyes here, although in this case you would be correct. And why do we know that? It's because E is on the 0 line, and B, that midpoint between opposite sides of a parallelogram, is also on the 0 line. So we know already the y of G must be 0. Our reasoning, we can see B is midpoint AC, therefore lies on EG. Right? B essentially becomes the midpoint of our entire structure. So we've got the y value here. If we think of E and G, they should be equally far apart from our midpoint B. So what's the x value of E? It's negative 11. Now, how do we know that? It's because of this equation here, right? So y equals negative x, negative 11. The y value of E is obviously 0. So 0 equals negative x, negative 11. So 11 equals negative x, therefore x equals -11. Okay, that's how I'm getting that value. Right, so distance of EB is equal to 11, and whatever the x value of B is, and I think, yeah, that is easy to work out. So B lies on this line that we have the equation for, right? Y equals 2x minus 8. Like E, the y value here should be 0. So 0 equals 2x minus 8. That means 8 equals 2x, that means 4 equals x. Right, so B's x value is 4. So this value should be 15, so that value should be 15. So the x of G should be 15. So G should be 15, 0. Alright, hope you're keeping up so far. I'll let that sink in a bit. Yeah. Okay, so now our circle has to correspond to this equation. Right? So it's y minus b squared plus x minus a squared. Hey. Sorry about that, just realized I made a mistake here. This must be 15 plus the value of b, which we know is 4. So g should be 19, 0. Okay, great. So here's our equation of a circle. We know what this b value is going to be. It's going to be that 0. We know what this a value is going to be. It's going to be that 19 that I just corrected. What about the r value though? That's the radius of the circle. Now, they asked us for a circle that passes through B. So the radius has to be exactly enough to reach B. Luckily, we already worked out here. The EB distance is 15, which has to be the same thing as the GB distance. Right? So the radius has to just be 15. Okay, now let's get this into the right form. They want us to put the x bracket first. No problem with that. This we may as well simplify to just y squared. And let's square the 15, 255. Okay, so a bit of a process here. I hope you can see where the logic is going. That is question 3. In the next video, we will look at question 4.